Lesson 5.1 Probability Rules. The objectives for this lesson is to understand the random processes and the law of large numbers, apply the rules of probabilities, compute and interpret probabilities for the empirical and classical method, and recognize and interpret subjective probabilities. Let's start off with a simulation. If you hold down the control button and click on this, it should pop up. And then you can just sign in and use your MyLab login. You can also just follow along. Go to Applets, Simulation, and Flipping a Coin. So probability of getting a heads is 0.5, 50% chance. So when we are flipping a coin, it's going to be difficult to predict what the proportion of heads or tails are going to be over a short run. So let's do about 5 runs here. Let's do another 5. So we're about 0.55. So this is pretty close, but the more runs that you do, the closer you are to be able to get to the proportion. So let's just do a couple more 1,000. You can see this proportion is getting pretty close to 0.5. So over many trials or flips, the proportion becomes easier to predict. So the result of any single trial, so when you flip a coin, is not known ahead of time, but over many trials, a pattern occurs, allowing for accurate prediction. So let's go on to some definitions here. What is random? This is an unpredictable result of outcome. A simulation, which I just showed you. The goal of a simulation is to measure how often a certain outcome is observed. So in our case, we were trying to figure out how often a heads would be observed. But that would be about 50% of the time, or 0.5. Define a random process. This represents scenarios where the outcome of any particular trial of an experiment is unknown, but the proportion or relative frequency that we learned in an earlier chapter, a particular outcome is observed, approaches a specific value. Let's move on to probability. This is the long-term proportion observed. So the probability of getting a head, so the long-term proportion, is 50%. The law of large numbers, as the number of repetitions of a probability experiment increases, the proportion with which a certain outcome is observed gets closer to the probability of the outcome. So the law of large numbers says the more, or as this trials increase of repetitions, the closer we are going to get to the probability of the outcome of 0.5 for heads. So what does in a random process, the trials are memoryless? So think of flipping a coin. You flip 5 heads in a row. What is your chance of getting a head on the 6th flip? It is still 50%, right? Because the trials are memoryless. So trials do not depend on what happened in the trial before. So you flip 5 heads in a row, you still have a 50% chance of getting heads on the 6th flip. So a family has 4 children, all girls. Is the family more likely on the 5th child to have a boy? So think of what we just did up above. They're memoryless, so no, they're equally likely the 5th child will be a boy or a girl. This law of averages, this is, people are like saying, well, I had 4 girls, I'm more likely now to have a boy. And so they come up with this so-called law of averages. This law is non-existent. Just because you had 4 girls doesn't mean you are more likely to have a boy on the 5th run. So law of averages does not exist. So in probability, what is an experiment? It is any process with uncertain results that can be repeated. Here is an example of that. So we have an insurance company cannot know whether a 16-year-old driver will have an accident over the course of a year. However, based on historical records, the company can be fairly certain that about 3 out of every 10 16-year-old male drivers will have a traffic accident during the course of a year. Therefore, of 825,000 male 16-year-old drivers, 825,000 repetitions of the experiment, the insurance company is fairly confident that about 38% or 247,500 will have an accident. This prediction helps to establish insurance rates for any particular 16-year-old driver. So this is an experiment in probability, just an example. So let's go on to defining sample space. It is all possible outcomes for the probability experiment. And then event is the outcomes from a probability experiment. So let's look at an example. A probability experiment consists of rolling a single 6-sided fair die. A fair die is one in which each possible outcome is equally likely. For example, rolling a 2 is just as likely as rolling a 5. Part A. Identify the outcomes of the probability experiment. So we have E sub 1 equaling rolling a 1. Also denoted by braces 1. And we're going to do this for each event. So now rolling a 2. All the way up to 6. Okay, let's look at sample space. Now, we want to know all the possible outcomes. So what's all the possible outcomes when you roll a dice? 1, 2, 3, 4, 5, 6. Now, we want to figure out what your E is. So what are the even numbers from your sample space? So your event should be a subset of your sample space. So look at your sample space and pull out all the even numbers. So 2, 4, and 6.